Welcome, everybody. It's Megabytes. My name is Marco,
And my name is Brandon.
and we are got some small bites with big knowledge today for you during this lunch hour.
All right. So I have VS Code shared on my screen here,
You do.
and I've got Amazon Q Developer set up, and I was just curious, how far can we take the capabilities of Q to build something?
That's a really good question, and I think we're going to answer it.
Yeah. So should we start high level? I'm just going to go to it's like a chat with your friends. Um, I'll just start by asking, can you help me build a simple neural network?
Simple neural network.
Yeah, simple
There we
one.
go. NumPy. That's a good one.
That's a
It's
good start.
good choice. That's a good choice. Weight initialization, and then we've got the layers right there, the forward propagation layer, backwards propagation layer, training code.
Okay,
Yeah,
so
that's a
here's
simple neural network. That's a
I
simple
mean,
neural
fair enough.
network.
Okay, so here's one of the things that I love about this. I'm just going to hit insert at cursor, and I've got this. All right. So it gives me a nice description. Okay, we've got a neural network with one hidden layer, sigmoid activation function, forward backward propagation, training method with configurable epochs. Okay, so here's one of the things that I've been curious about. You can actually tell it. I think I do have to save this real quick. I'll just stick it on my desktop. Give it a super unique and meaningful name. So I can say something like, can you explain what the code in test.py does? Because maybe someone sent me a file and it's like, I'm not 100%, like maybe it's pages long, let's find out how good the answer is here in terms of explaining it. Okay.
It's analyzing it
Yep.
and it's giving good content. Yeah, it's returning good content. Now, how do we know that it's not picking this up for what it created from before? How do we know it's not from the memory?
That's a good question. And I think I have an idea here.
Go ahead.
So one of the things that I've noticed with Q is if I highlight this and I say, can you explain the highlighted text and what it does? Just as you say, to confirm this isn't just grabbing something from memory. So right there, we can see it grab the train definition, breaking it down, its method parameters, training loop. Okay, so it has the ability to actually focus in on a piece of code, or it can talk the hypothetical. Like so much of what we do in any type of artificial intelligence is context, right, Marco?
Yeah. Now,
Like,
what we could also do is use the slash commands. We can do slash clear, which clears the session information, including the memory of what it created previously.
okay,
So if you click slash, if you just type in slash, and then you can click on these actions, right?
yep,
Clear this session means it's completely clearing what it's done. So if you
all right,
ask it now what's in the highlighted code, it has no information of what it created previously.
okay.
So
And
let's
let's
try if
pick
it
a
does the
different
same.
section.
Perfect.
Should we try a different section or the same?
It's the same section, different section. Let's just see what it does on any of these sections and
All
see
right,
whether it's capturing data from the previous conversation memory or is it actually reading a fresh portion of data and yeah. answering
Okay.
based on that.
So I've just asked in the chat here, can you explain the highlighted section to me? And it's the same piece as before.
Yeah, there you go.
All right. So yeah,
And
it appears to be able to read what I am telling it. But let's think about, like, what are some questions that we might ask of a developer when they're tasked with building something. Like, it's probably not going to be this loose, but like, should we ask, is this code going to scale for production? And are there any, what would we call it, optimizations, maybe just improvements? Because basically we're asking it to think about it in terms of scale and, like, can it improve on what it originally suggested? Is
yeah,
that fair?
that's what you would ask as an associate developer, or as a developer. You'd go to your senior and principal developer and you could say, I've got this code, I wrote it, whatever. And you
Right.
say, is this something that you think is going to scale in production? Do you have any improvements? And that's what your senior principal is going to return and say, yeah, I think you should do this. And I don't
Yeah.
know if it's going to scale in production unless we do that. So
Okay.
here, Amazon Q is taking that position of the experienced developer and can analyze and answer questions that an experienced developer would.
Yeah. So let's see what it has to say.
Ooh, I like it.
Yeah.
I already like it.
Early stopping and validation. Yeah, okay. And then it's got, I like that it gives you the explanation, things that you might not have even, like, okay, yeah, memory management, GP. Oh yeah, regularization. That's kind of, yeah, okay, makes sense.
That's the bullet points down at the bottom are good for production. I'd recommend using frameworks like PyTorch or TensorFlow
So
because NumPy is like basic stuff. It's
yeah,
really useful for working with matrices or converting them before you drop them into the model, for working with just math type data. But it's not as powerful as PyTorch or TensorFlow or any other framework at that
well,
in that
that's a
respect.
good point. And that's okay. So we're coming into this with some previous knowledge, but
Yeah.
let's say that we're someone who, I mean, you're trying to learn, you're using Amazon Q. So maybe we say, all right, it says PyTorch and TensorFlow. So maybe I just ask a follow-up question.
Sure.
Should this be rewritten as either PyTorch or TensorFlow?
Ooh, it's
Okay.
got a torch example. Nice.
Yes. And I'm guessing,
Lovely. Cool.
and here's the TensorFlow version.
Nice. Now, obviously, these are super, super simple neural networks. This is not something complex or production ready. But based on what we see here, it can convert from one code or one language or one framework to another one.
Yeah. So maybe, well, it's thoughtfully given us a list of reasons why you might pick PyTorch or TensorFlow. Um, since we asked it about production scale, should we go with the TensorFlow and run with that and see where it leads us?
Yeah, let's go. Let's choose TensorFlow as our chosen framework and say, hey, let's build, I don't know, 20 layers. Let's say 20 layers. Let's do like early stopping something that will be kind of useful.
So I was going to take this in baby steps.
Sure, yeah,
And I
go
said,
baby step it. I'm just
yeah,
outlining
no,
what
I
my
see where you're
next
going.
step would be. You can go baby
So I
step
just
it.
said, I think TensorFlow is the better choice. Can you help me update the existing code to reflect that change? Because I think it's helpful to be able to see the ability to swap pieces too. And I like your idea. Let's tell it one of the requirements is, how many hidden layers do you want? I don't know how well you can see this on your screen,
Well
but
enough, yeah.
it's including comments.
Yeah, that's the good thing about how the structure of what Q produces is essentially done through best practices for writing code, where you're supposed to comment everything in the sense of, what this code does. You're still gonna have to tell it about the decisions you make. You're still gonna have to put the comments about decisions you make when you're updating the code yourself. This is not gonna write, updating weights and biases, because it's gonna say this portion of code updates weights and biases. But sometimes you're updating weights and biases to a specific set of parameters, and that's because you have a specific reason, and that production code at the end needs to have that information in there in the comments.
Right. Yeah.
That's one of the key things that we need to know about Q is it's not going to just write all the code for us, but it gives us good templates on which we can then build our functions at the end of the day.
And I think to that point, I will describe comments and tags as the always, never, sometimes tool that we use as developers, right? Sometimes we're really good at it. Other times we're not.
Yeah.
It just, as you say, it helps to have that template. So I'm going to delete this and I'm going to get out of Vim mode.
Yeah, let's just replace it with the tensor code.
Yep, let's do that.
Yeah. I want to also see what this code looks like with the previous, where it said like, here's an example of PyTorch, here's an example of Tensor. So if
Sure,
you
you
go
want to go
up
back up
and let's just see what it created. Oh, so it's created like a very compressed version. Whereas now when you ask this to do the same thing, it's giving you a little bit more of an expanded version of the code.
Yep.
Keras, it's done the beautiful. I love that it's done the logger, because you're gonna want to have logging in production. Errors, error catchers. Yeah. Try accept. That's good. That's good. Now,
okay.
I'm no developer. I don't develop as a daily activity. That I know best practices for developing.
Yeah, I'm not a developer, but I did play one on TV once.
Yeah, I play one on WebEx.
Yeah.
I've written some code, but it's mostly code that you would not want to put in production. And this doesn't look anything like my code.
Yeah, well, for one thing, it has comments. That's a slight against me.
Number one, and for second, it's got error catchers, right?
Yes.
And logging.
They'll figure it out in post.
Loggers and error catchers are the things that I always kind of struggle with. Because it's not the functional part of the code, it's the thing that you kind of have to put in to see when it works in production at scale, because it's running on 1,000 instances, and you're not gonna be troubleshooting 1,000 instances by manually going and running each one.
No.
For my intents and purposes, all my code is ran on one instance. So I'm that
scale question.
That old school developer that actually looks at the log outputs. that does verbose, always like a dash VVV on the
Yes,
command
exactly.
line.
Give me the long form.
A dash VVV on the command line to get to the bug outputs.
So
But
should we ask it to that end? Should we ask it the same question about scaling?
we can, yeah. Yeah, go ahead.
Now, to our earlier context question, I can say, will this scale? And I will assume it knows what I'm talking about. But other ways is if I highlight the text, I can specify highlighted text, or I can say, will test.py, the file, scale for production? And then we're sure it's talking about the same thing and not some previous in-memory iteration.
Cool. Let's do that. Distributed training support. This will scale in production. Got memory management built in. Yeah.
Even more health checks and monitoring. That's good.
It's what you want to have.
We're kind of big about monitoring at AWS.
Yeah. Monitoring observability,
Yeah.
the fancy terms. What I also like about Q is that it does know how to write unit tests. That one of the favorite things developers love to do is write unit tests for their code so they have good code coverage. And I find that the unit tests that Q comes up with are pretty good. And you can just ask it, hey, can you write a unit test for test.py?
Let's see what it says.
Mm-hmm. Comprehensive unit test, PyTest, TensorFlow, NumPy, sample neural network. So what is it testing? Initialization, it builds sigmoid function, looks at validation. Yeah, it's pretty comprehensive in my opinion. And it gives you like a few arrays to try.
It actually said it was a
and see if they
look.
work.
So I mean, yeah, this is impressive.
Yeah. And this is where a lot of sort of production use cases come from for Q developer. It's we've got a bunch of code. We've been pretty bad about unit testing it, about having good code coverage, about integrating this stuff into our CI/CD pipeline. So what it gives you is all the code that's gonna roughly mostly work out of the box with maybe a few minor tweaks here and there. It's gonna give you an integration like PyTest integration. You can drop that into your command line, into your CI/CD server, or just like if you're doing it on AWS, you can run that command as part of code build. And you've got your unit tests built into the actual build process, right there. That's all you copy paste, right?
Right, exactly. And I mean, it even gives you instructions.
Yeah.
Install PyTest, create a new file, name it testneuralnetwork.py, run the test for the specific test category, and then it's even got output. I mean, it's really comprehensive.
You can make a new file, take the unit test, save it as unit test py.test.py, right? And then you can deliver those two files into your repository, and you're done with your job for the day. And that's it, right? Spend 5 minutes a day coding.
Yeah, right. Well, let's try. Let's pick one of these. Memory management, performance monitor. Let's pick one of the production ideas that have and see how good it is at helping us integrate it. I don't know, Marco, what's standing out to you? Pipeline scalability, distributed training and support.
I like the distributed training support.
All right. I want to include your suggestion for distributed training support to test.py. Can you help me do that? Okay, so it actually handed me. Wow, okay. So let's go and let's grab. I'm trying to think how to follow up a question just to demonstrate its ability. So, where should I add that large code block to the existing code? See what I'm doing here?
Yeah, I see. You wanted to tell you the line at which you should add this code. Now, general purpose, this kind of stuff, like your base neural network and then your distributed configuration, I would keep these in 2 files. I wouldn't jam the same thing
One
into both
giant
files. That's just
document.
a
Yeah.
general good practice. And then you can call another Python file from the code. It doesn't necessarily, if you want to integrate it into the same code, and you just say, okay, call up distributed training. You could even add that as a section in your code. Say, this is the distributed training code. If you want to enable distributed training, then just uncomment this link to this distributed test py.
Yeah.
If you want to do unit testing,
that's a good best practice to call.
Yeah, if you want to do unit testing, do this py thing. Even better, you actually go and say test py is my neural network, distributed training is my file, unit test is my file, and then you assemble a coordinator or like an orchestrator file in which you just call up other scripts so that you don't change the orchestrator, so that you can then customize the orchestrator into different ways of calling things. You could even build a pipeline. So if you use like MLflow, if you use SageMaker pipelines, what you're doing essentially is calling services, and you don't want to have code in the pipeline. You want to have the pipeline defined separately from the code anyway. So now in the pipeline, you're going to be calling these files, these Python, essentially like custom libraries of code. These are your custom libraries essentially now, because you can reuse these. You can refer to them as quote unquote custom libraries at the end of the day.
I like that. So let's take a look at this, and then let's ask it. Should we break this into multiple? Let's see what it comes up with. So just for those of you following along, the code I provided is actually a complete replacement. However, it shows you how to substitute the existing code. So it says you'll add this after the imports and logging section. So I can go in and find that. Yeah. And then I add this and I can literally pop it in. Just for the purpose of speed and simplicity, we'll go ahead and do a full swap because I want to get to Marco's question. Oh, that's it. Now that I have updated the code, so hopefully it can reference that in test.py, do you think this should all be one file, or should we break it into smaller files for easier management. Is that fair?
That's good. Yeah, I like it.
Let's see what it comes back with.
There you go.
Nice. Even with a thoughtfully laid out chart.
Yeah. That's the way you should write your code. Beautiful. And it's writing out the files for you.
Yes, that's awesome. Yeah, so it's an awfully helpful tool.
Yeah.
And this is another thing too that we can do if so, just for fun. I'll let it finish here so I feel rude like I'm interrupting it. It's not a human being. If I run the code, let's find out what happens. And it's always kind of interesting because you can actually grab errors and put right in there, and it will say, oh, well, why don't we just take a look at it?
Nice. Model, simple neural network. No shape of the output. File path, checkpoints, best model. Okay, so we're missing.
Well, let's ask Q.
Yeah, SQ, yeah.
And I don't think I can capture.
That's
I'm
fine.
not
That's
sure.
fine. You can just capture the error itself.
Yeah, let's
Because
just
the
leave it.
total parameters, trainable parameters, all of those are not necessary.
All
You
right.
can ask it why this error came up.
Code. I got this error. Now, what's interesting is I don't even have to follow up with, can you help me figure this out?
It's going to
It's
figure it
going to
out.
right away, it'll start explaining, hopefully. We'll see what it does with an audience. All right, so returning to the top, it says the error occurs because of a recent change in TensorFlow Keras that require the .keras extension for model checkpoints. Let's fix this in the trainer.py file. Here's the corrected version.
Yeah, so this is now referencing the files that it kind of created for you in the file structure. You should now say apply these changes to test.py.
That's a good idea.
Because we didn't build the trainer and model utils and main and all the other decomposed files yet. See, I confused it by trying to uphold some standards, some best practices.
Yep.
I caused that whole confusion, but it's gonna write out that big, massive file for you. Big, massive code set. How many lines do we have here? Quite a few,
huh? 207, which is not bad for what, 10 minutes of work?
Yeah. I mean, line by line, if we had multiple files, there would be more lines of code. But
well, even I just think about before Q, like maybe you find something on Stack Overflow to springboard things for you, but that's a lot of manual work we've just avoided.
Oh yeah.
Okay, and I'm just going to ask for clarity. Should I add this new code to the existing, or should I just replace? Okay, so this is actually it's kind of nice. It's making a suggestion here.
Mm-hmm.
You should replace the entire code or the entire content of test.py with this new code. The new version includes all the functionality of the previous version, which is a nice reassurance, plus the necessary fixes for the .keras extension and improved path handling. Okay, well, that's exactly what we asked it for. So we'll do as it said.
We'll do as it said. We'll just replace everything without
Blindly
a
replace it.
backup.
Yep. This, by the way, is probably not the best demonstration of how things should work in production, but you get the idea. Okay, so let's try running the same test again and see if that fixed the problem or if we have new problems.
Ooh.
Okay.
We got some. We went some. Yeah, we went a little bit out of range. Well, what are we training on? We don't have any input data, do we?
No.
So we need to like train on some specific input data.
But
let's ask Q. Let's not speculate. Let's ask Q.
I have a new error when I run test.py. And here you can see I've literally just grabbed the output from the terminal.
You know the cool thing about these models? You could even like make typos and you could just say, I have error. You don't need to be perfect. You don't need to describe it in those human type terms.
That's true.
It'll still understand what you're trying to say. Even if you just paste the error, it's gonna.
So I could do
pretty
like
much do the same.
Stat face and then post the error. Oh yeah, you probably just post the error.
So you're being really nice by trying to correct your typos, and I don't. I just like I type like a monkey, and then
when AI takes over the world, I think it'll remember who its friends were.
Oh my god.
All right, so at the top here it says, this error typically occurs when the data set is too small for the batch size and distribution strategy. Let's fix this by fixing the batch size and adding some data validation. Here is the corrected version. Okay, well, let's, in the interest of
science,
there's the updated code. It's truncated quite a bit. We lost about 50 lines there.
Like 80 lines. It was like 235 lines before.
Okay.
We had quite a big reduction here, but let's see.
Let's see.
That's why you do backups, people.
This is funny.
That's why you don't do things like
All right, so I'm going to take your advice. I'm just going to, here's the error.
Yeah. Don't do troubleshooting like Brandon does.
Amazon Q, can you
Dearest Amazon Q, this is your friend Brandon.
I have had the most frightful error.
I am trying to record a megabytes with Marco, and we're trying to show your best functionality. Why do you not please give us your best code? Give me your best code.
Yeah. Okay. So here it says the error occurs because we need to define the path constants. Okay. Let's fix this by moving the path definitions to the top of the file after the imports. Here's the corrected beginning. So now here we're not getting, because I think it's starting to, we're hitting the maximum boundaries of what it probably can pack into a single. So let's just ask it.
I don't think that we're hitting a boundary. I think that we might be limited by the design.
Possibly.
We might be limited by how many tokens it has in its memory. We might be limited by, how much it remembers of the history. The problem with sessions is they start to get pretty dense with information. If you think about it, the model needs to remember everything that needs to put in the memory, all requests, all prompts, and all responses, everything that it generates. And that can be pretty bulky. I mean, it's a few kilobytes here and a few kilobytes there, but as you're adding this to memory, at some point, there's only this, like, a limited physical amount of memory in existence. There's millions of users using it. So a kilobyte here, a kilobyte there, it's going to start truncating and summarizing what it did before.
So you remember earlier when we just blindly copied and pasted? Look at the top of our file here.
Oh, nice.
Yeah, that's why. Okay.
Okay.
So it's saying basically we probably need to still import TensorFlow as TF. Good call, Q. Good call. Okay.
That's why we lost 80 lines of code.
But no, the code. So I'm a cautious and nervous sort. I'm gonna go ahead and I'm gonna highlight this and say I added the highlighted code. Can you confirm it is in the right place and will solve the error?
That's fair enough, yeah. And we're also learning.
Yeah, it turns out the imports at the top, super important. Absolutely critical.
Yeah, that
The
because
one time I don't ask the clarifying question, like, is this the whole thing? Like, no, it wasn't. Okay. Looking at the highlighted code, I can confirm you've added the path definitions exactly right. It gives you the example. This is the correct location. Okay, so let's try running it again. Oh, this is interesting. Do you see the angry squiggly red underline? Let's see what happens here. Unexpected indent. All right.
I think those are indented too far.
Let's take a peek at what Q comes back with.
Yeah.
Okay, it actually found, it says right there, get distribution strategy.
All right.
Oops.
We can do that, yeah.
All right, so it says, look in the code, it seems like you've got that wrong place. The function isn't properly closed. Here's how to fix the problem. And then we see prepare
everything
data.
up to prepare data, yeah. So
Right
up
there.
to line 32.
Yep, so yes, okay.
Yeah.
So I'll grab this and I'll delete, then I'll insert.
That should technically be.
Yeah, and for those of you following along at home, the fact it turned yellow and I lost my angry red line here tells us that we've resolved that.
Yeah.
But I mean, it's nice that it was able to isolate the exact line and say, hey, this is where the problem is and this is how you fix it.
And yeah, especially if you're like on your 4th or 5th indent. And then you're like,
I'm thinking about like,
where do I need to, how far do I need to push this back or forward?
With me. How do I fix it? Here's the spot.
Yeah. How do I push it forward? How do I indent it more or remove indentation?
All right.
Yeah, I think we lost.
We lost something.
More. More than just
one time I didn't ask.
See, when it's suggested, okay, now take your test pi and save it as test_backup_pi.
So
and you're like, okay, for the purpose of science,
don't blindly copy and paste what it gives you. You need to ask the clarifying questions or at least read what it's handing you. All right. So
let's copy paste the whole code. Let's copy paste the whole code. Oh, look, we've optimized it. We lost 80 lines.
Wow.
I don't think that was an optimization. Those 80 lines we lost, to be perfectly honest.
All right. So it prudently says we need to add the simple neural network class definition. The class should be added after the imports and before the main execution block. And it says, here's where you'd add it. So we have our imports, just like it says.
After the logging.
Yep.
Just drop it in between the, yeah, like there. Yeah, that's perfect. Fair enough. That should be.
I just said, does it look like the highlighted code is in the right place? Okay, this is a good sign.
A good sign of
Yep.
being able to troubleshoot the next error now.
Yes. I like that we both just blindly copied it over and like, yeah, it's shorter. That's awesome.
Ooh, look, we got our training back.
Yes, it's looking better. We have 2 errors.
Training failed. We started something.
We did. Let's find out.
We got a 50% accuracy. Flip
Hey.
the coin accuracy.
I've seen worse. I've seen worse.
Oh, yeah.
Okay. The error is occurring because we need to add the save model function and adjust the training parameters. Here's what we need to add and modify. First, add the save model function. Then modify the train model function. All right, so let's try something just for fun. Could you add those updates to the full code block so I can just insert at cursor and save time? Will it rewrite the whole thing?
I mean, you couldn't have written it nicer. Maybe even say please at the end. I don't know.
Oh yeah.
Please and thank you.
Please and thank you. Q, remember your friends, okay?
Here's the compile code. You could test, do everything. Okay, let's see.
I did notice it has the imports this time, which that's a really good sign. This is a fairly lengthy piece of code at this point. I'm surprised. Like, apparently we haven't found the maximum boundary yet.
Yeah, this is a very long it's a very long set of code, a very long file that it's generating, and it's pretty impressive that it does generate this big of a chunk of a code, because typically it just does
Right.
snippets.
I mean, at this point, think about all of the things that we've specified that we're asking it for, and it's remembering that and updating accordingly. So I was kind of following along with it, and like it does actually appear to be a little less blindly this time. Copy and paste, and we're back to where are we at? We're at 240 lines. So
there you go.
there we go.
There you go.
Not
We're
as
like optimized it now. Now we've de-optimized it. Hey, there.
Hey! Now, here's
Whoa.
something.
I
This is
think we
technical.
trained it.
Check this out. So we can give it the last few lines here. Can you explain these outputs to me?
Accuracy 62.
It's better than it was.
It's better than coin toss. I wouldn't bet on a 62% on my day-to-day work, especially like The thing
Okay.
is, 62% is not betting on one horse that has 62% chance of winning. It's on the thousands of horses that have a 62% chance of winning. So that's not a very, very productive bet.
That's true. That's one way to look at it.
Yeah. And you want to go into the 90s, but for the few seconds that the neural network ran to even improve above 50%, which, just to be clear, 50% is zero. It's completely inaccurate.
Right.
It's 100% loss if you're 50%, because it's like, maybe it will win, maybe it won't win. So the fact that it runs across a tiny little data set and gives us 62% accuracy is actually,
Yeah.
it's not bad.
If it was a lottery, I'd feel pretty lucky.
For one number, for one set of numbers. Does this set of numbers have, that's a good use case for this kind of prediction. These were the last lottery numbers. Predict the next lottery numbers.
Yeah, you heard it here first, folks. Q will help you. No, I'm not even going to finish that sentence. Okay, so it actually has a suggestion, and I think this is decent because we were talking about production scale and actually, well, it's a hidden layer, more hidden layers. All right, so
more hidden layers and more data. That's what we need.
Yeah, or as we like to say in the business, it needs more cowbell.
Yeah. So you've got what, 11 epochs now. How many epochs did it do at the end? Can you scroll the bottom of the output?
Yep, it's 11.
11 epochs. So 11 epochs, that's nothing, right? But you have a very tiny training data set. So we need to have a bigger data set. We need to have more hidden layers. So you ask it to synthesize a bigger data set as well.
All right, let's do that. And then, yeah, let's ask for a bigger data set.
So you just said add more hidden layers. Okay, cool.
More! Always better.
Add more hidden layers.
Change the activation function to a ReLU for hidden layers. Okay. Now, do we want to go hunt?
Yeah.
And find exactly where to put this, or should we ask it? Will you just rewrite the whole thing for me?
I mean, if we were lazy, let's try the hunt this time.
Let's try the hunt. Okay.
Let's try the hunt this time to see how well we can recognize what the previous code was like and where we should replace and what we should replace.
All right. So we found our class, our simple neural network.
And where does it end?
It never ends, Marco.
It does.
All right. So we've got our defined model architectures. Dropout for regularization, the distribution strategy.
Yep, and it stops. That's where it stops already.
Yep, at the distribution right here.
Yep.
So if I go, no, I need to hold down shift.
There you go. That's what we've hunted for. And now we're going to insert that at
reserves. I have to delete first.
You have to delete and then insert that. There you go. That should be.
All right. Then in the main execution block, update these parameters.
The strategy scope.
Let's see if I can quickly locate that.
There we go.
I don't think that's the one.
Strategy scope.
I'm sorry. Do you see it on the screen? Because
strategy.scope. You're looking for strategy scope.
I see.
There we go.
Yes.
With strategy scope, you're going to want to replace that. And then in the train model function, update the train model strategy. This goes in the train model function because it's not the full code.
Yep.
So we're going to go to train model. That's exactly. It's exactly what we need. So that one line goes in the train model. There we go. Train underscore model strategy. Wait, what is it doing now? History is train model. No. Define train model. Search for def space train. There we go. You want to change that line. You want to replace that line, the training line.
And I have to do the...
Yeah.
Because it gave it to me as...
Just copy paste, yeah.
2 snips.
There we go.
All right, and I do see we have some angry red.
Do we? We don't.
Yeah, it's showing red at the top here, and I can
Is
see.
it?
Let's see.
Return history.
Oh,
Okay,
okay.
ask it.
Yep.
Ask where the error is.
Oh, good idea, even before.
Yeah, ask it before you run it. Ask it.
Actually, in... I'll be interested to see if it can find it.
Yeah. So just hover over. Return can be used within a function pylance. Give it that error.
Lighted the red error.
Red error. Doesn't know what error. Red error. Yeah, it doesn't know what you mean by red error. Okay. Hover over the error.
There's another way to do this.
Sure. There is another way to do this, yeah. There is another way. Let's run the code. I mean, you would do that in production, wouldn't you? Yep. You would run your pipeline and you'd get an error from your pipeline.
Check it out. Ah, I see the issue. There's a problem with train model function definition. The return history statement is not properly indented within the function. Here's the correct indentation of the train model. So let's
go. So you got the train models function, yeah.
Model.
Up, search up. You're going too low.
Def train.
There you go, def train model, yeah.
And I'm wondering if we can just eyeball this.
Yeah, keep going.
So
it's going to be through the return history. Through return history. There you go. Through number 190.
Yeah, it's got to be indented line, right?
Yeah. So it's an indent through 190 from 148, actually. So you're replacing code from 148, the def train, till 190. There we go.
Oh, okay. I was just going to hit the indent button, but...
Oh, you just hit the... Yeah, okay, sure. I mean...
This works too.
He gave you the code, right? So...
Yeah, why not use it?
Yeah. I mean, you're paying for it, right?
Paying for the expert advice.
Yeah.
Okay. That does seem to have resolved the issue.
There you go.
So now let's run it and see what happens.
Yo, we're worse.
Wow. All right.
We're worse. No, we're not worse. We're 69. It's good. It's almost 70%. It's not bad.
You said worse, and I looked at it and I saw the 5-1. I didn't sketch the 69. I was like, oh my gosh, we did make it worse.
So what is it giving us suggestions?
Let's take a
Increase capacity. The model is still not learning the pattern effective prediction around and validation accuracy is 0. Substantial training parameters. Okay. So it's the neural network training parameters that he wants to update. Update the training parameters in the main execution block. Let's go see what it's saying under there. Increase the network capacity to 32 to 120. Yeah, so yeah, well, yeah, obviously our
The more epoch.
how many layers do we have
actually
right now?
finish
Like
the
4 or
epoch,
something.
yeah.
It's we could now spend hours trying to figure out what the right scaling of this neural network is to make improvements. We could take hours to do that. But to be perfectly honest, this is really good. This is really good stuff is coming up with.
Yeah, it's pretty impressive. And I've just given it the lazy.
Oh,
I'd like to just copy and paste one giant.
the Brandon way.
Well, we saw what happened when we did it the other way. We failed.
True. We had to ask it again. True. We're not developers, remember. Not being a developer and being able to do this is a significant improvement in technology that
Yes.
5 years ago you wouldn't be able to do this right now. 5 years ago, it takes what, several university courses to get to be able to write this code. And
Or,
now it's
5,000 hours of sitting and working with the code to get to that level of mastery.
Yeah, now it's Brandon saying, just rewrite the whole code for me. God
Yes,
damn it.
finally, my liberal arts training is paying off. Hey, we're up to 75.
Yeah, well,
Its predict is still really low.
I mean, the training accuracy went to 100% at some point. Validation is actually not bad. Validation is actually not bad. Yeah.
So you're right. We could spend hours, and if left to our own devices, we probably will.
Validation is actually 0 to infinity. Yeah, so validation is like, yeah, it's completely wrong. But it's like we're overfitting dramatically right now.
Yes.
Yeah, I was looking at the loss. I thought that was an accuracy.
Should we ask it something like, hey, could we try training this with a different, with different data, or something to make it more lively in its approach?
What are you trying to write, Brandon?
It doesn't need to know why. Okay, so fair enough. It says it's I'm asking for it to do something outside of its area of expertise, which is fair.
Yeah. That's an accurate and appropriate way of responding to this kind of request, because it's not supposed to be a general model here. It's supposed to be a coding assistant.
Specific. So what else can you think of anything else that you want to try or that you want to ask it about?
No, I'm pretty impressed that in what we've spent about an hour, and we've gotten from 0
nothing.
Yeah, nothing, just some NumPy code for a neural network, to PyTorch code for a neural network, to distributed code, to the proper structure in many different files, and it gave us the files and said, this is what you put in each file, how you name it, to then messing around with the actual code to make it work. I think that's pretty impressive from my point of view, from somebody who has not enough knowledge to be able to code this myself.
Right, and that's the thing, is it's designed like you said. It's exactly like, well, hey, I'm a junior developer. I'm kind of getting my start. I'm looking to learn, and I need the expert advice of, that tier 7, that tier 8 developer who's been doing this for quite a while, but they don't always have time. So can Cube help fill in some of those gaps? Well, it turns out, yes, yeah, it can.
Maybe it would be also something like, I'm trying to use a new service. I am an experienced developer, but I've never used this service before. How do I take my code and deploy it to this specific service? This what we could ask it right now. To be perfectly honest, we can take this code and say, how do we deploy this on SageMaker? So you could type that in, and we'll see whether it comes up with, whether it comes up with some decent code for us to use on SageMaker. Ah, okay.
Create the inference. Okay. The deployment script.
Beautiful.
Set up your credentials, have the CLI installed.
So what it's taking these, so if you want to scroll up a little bit and we can go through the examples here. So the directory structure, why does it create that directory structure? Because that's the sort of structure that SageMaker expect in a deployment package. And this deployment package could be a container, it could be a Docker container, could be a zip file as well. And you'd just say, hey, this is my deployment package. You make this structure. If the model structure is, if the algorithm structure, model structure, whatever you're trying to use is what it is right here, then SageMaker will know how to use it natively. This is the structure that SageMaker containers use internally. So if you structure code like this, boom, it works. Modify your training code so that it uses SageMaker. Instead of the neural network running on your local machine, it'll now be able to use SageMaker instances, call them up through the SageMaker API, spin them up, and run on those SageMaker instances. And then what do we have next? Deployment script. Yeah, so deployment script, so that we create a fit function for that to run on specific instances. This is where we can then play around with things like instance sizes. This is where we can play around with numbers of instances, batches, epochs. So we can kind of use those capabilities, the programmatic capabilities of SageMaker, to actually scale our environment instead of using a local environment like you've been doing it on your local computer. And yeah, the credentials are the stuff that you need for your SageMaker to run. Obviously, you need to have permissions to use SageMaker. Nothing runs without permissions, least privilege.
Yep,
We all know that.
Opinion. It always does. So you actually brought up a really good point. So we can see it's built using TensorFlow 2.0, NumPy 1.19. So let's. I mean, this is a relevant question I think senior and junior developers might have. Can you recommend a SageMaker instance type and size for this code? Not sure if that will be outside its purview, but I'll be interested to see what it comes back with.
M5 large, T3 medium. Yeah. Those are good recommendations. They're actually good recommendations to start with. Now, in reality, the way we choose instances would be based on the performance of your model, based on like a data set. You push it into your model and you see the performance. On SageMaker, you actually have a instance recommendation tool, and it will spin up your model on different instance sizes, instance types, maybe CPU optimized, maybe M type instances, the general purpose ones. Maybe it's going to use a GPU instance if you select that you want to try it on a GPU, and if your model is GPU compatible, like most TensorFlow models will be able to utilize a GPU. If you're running something on a GPU, you can see, okay, the GPU did the job in 10 seconds, and my CPU model did the job in 60 seconds. And then you can compare what does the 10-second job cost versus a 60-second job, and you can take an informed decision of which types of instances you're going to actually go ahead and use in your training, so that you have that cost optimization for your training jobs.
Somewhere between the performance you're looking for and the cost of the actual instance, somewhere in between there is your perfect instance.
Exactly. The instance that's perfectly utilized, you'll see as you add CPUs, you'll see more performance. If let's say it's a CPU model, Doesn't matter if it's a GPU model, you're probably scaling up until the maximum size of GPUs, because like a P5 48XL instance has 8 NVIDIA H200 GPUs, and like most training will take the benefit of all the instances, of all the GPUs that you give it. But that thing is expensive. That thing is, it's $250,000 worth of NVIDIA cards in one of those instances. So it's not a cheap instance to use. But when you're doing training on CPU instances, you'll find like an M5 extra large with like 2 CPUs will do better than an M5 large, and then a 2 extra large will do even better. But then a 4 extra large will stop doing better. It will do maybe a little bit better, but not enough to justify. It's not going to be double performance at a 4 extra large or an 8 extra large or larger instance. So when you're doing CPU models, you need to find that peak one that still doubles your performance, because you're going to reduce training time. And it doesn't matter whether you use 2 large instances or 1 extra large instance, if the 2 large instances are going to take a longer time to process. You'd prefer to use the fastest and the most well utilized instance. And yeah, that's your sweet spot between your time, your cost of your instance. And a lot of the times it does make sense. If you have time, it does make sense to use CPU instances to train. And then if you can write for the new infrastructure, the Trainium instances, the ones that were just recently updated to Trainium 2, the second generation, if you can rewrite your code to the Neuron API, well, then you're going to be winning with like 50% less cost at the same performance level. You can also, there's also like a translator from CUDA to Neuron. So you can use like, if you're running on NVIDIA GPUs and you want to optimize that code for Neuron, there is a translator that can translate your code. It's based on the same kind of principles that Amazon Q uses. So it's a fairly simple way to rewrite your code so that it fits on Neuron. One of the models, Anthropic's Claude, is trained on Trainium.
Yep.
So they're trained on Trainium, so it's very efficient to run inference on Claude, and that's why it's so inexpensive. Especially the newer versions are so inexpensive because they all run on the Inferentia chips then. So anything you train on Trainium, you can run on Inferentia for inference in production, and that can be like 10 times cheaper than running a GPU to run your model. I tested the DeepSeek R1 recently, and it requires that 48 extra large instance. It requires at least 800 gigabytes of NVIDIA memory, high bandwidth GPU memory. And that box has like just over 1 terabyte of that memory. But when you visibly see the price of that solution increasing, well, then you kind of like are, okay, am I gonna really use this for production? Or should I use a model that can run 10 times cheaper on an Inferentia instance that I can run? So yeah, that's consideration. That's your how to find the best performance. That's like some advice on It's not as simple as it looks. It's not like, oh yeah, you just drop it on Nvidia. You drop it on Nvidia. Oh well, first, if you can even get those cards, they're pretty expensive. They're
Well,
pretty
it's
expensive.
one of those things. I have never encountered a company, and that's through years of consulting, years of working in IT. I've never found a company that is like, hey, we don't care about security or cost. That never happens. Those are always two things that are right up towards the top of the list when you talk about priorities at a company. So yeah, it's very important to have the knowledge to be able to pick the right thing for cost optimization. So should we
Cost,
go?
definitely. I've encountered companies that said we only care about cost. But for now,
I'll say indeed.
yeah, for now, I think Brandon's last word will be
Indeed.